So Joanna Zylinska is a writer, lecturer, artist, and curator working in the areas of new technologies and new media, ethics, photography, and art. She is professor of new media and communications and co-head of the Department of Media and Communications at Goldsmiths, University of London. Zylinska is the author of 7 books, most recently AI Art, Machine Visions, and Warped Dreams, published earlier this year by Open Humanities Press, which means it's e-version freely available. Then she's the author of The End of Man, a feminist counter-apocalypse, University of Minnesota Press, 2018, Non-Human Photography, published by MIT Press, 2017, and Minimal Ethics for the Anthropocene, Open Humanities Press, published in 2014, and e-version is available. Thank you very much.
Thank you. Just wanted to start by thanking the organizers, Bojana Romnic, Bo Reimer, and Richard Topgart, for inviting me, for organizing, for putting so much work into making it all work and run rather smoothly, and for creating such an interesting intellectual ambience under what are very strange circumstances. I'd like to start by showing a short video work of mine, which is just completed, to introduce key themes of this lecture.
Can machines see? What does it mean for humans to endow machines with a capacity for seeing? And what does it mean to classify us seeing machines' ability to differentiate between objects on the basis of the light reflected of them and transmitted as data to those machines' processors? But is it actually clear how humans see the world? And is there even a human eye that does the seeing? Are humans in fact seeing machines?
Okay, so the whole piece is over 6 minutes long, and to make it, I reanimated, with the help of a big GAN algorithm, some historical and contemporary images of eyes and brains from the Wellcome Collection, which is a collection of medical images in the UK, to raise some questions about perception unfolding between the eye, the brain, and the world in humans and machines. Now, the problem of machine vision in relation to creativity and art has been of interest to me for a long time. And I recently published this short book titled AI Art, Machine Visions and Warped Dreams. And here's a shout out to my colleagues at Open Humanities Press, who make a lot of books available for free. It's a scholar-led initiative. So there is lots of free books under this address. If people don't know Open Humanities, I would recommend it. So the AI Art book was an opening for me to start probing the problem of machine vision, while today's talk attempts to kind of add a little bit of depth and maybe conceptual philosophical interrogation to that. The book offered a polemic about different ways of seeing and viewing art at a time of the rise of machine creativity driven by so-called AI. And I say that some rather critical things about GANs, generative adversarial networks, aesthetics, about which we've had a number of interesting presentations during this conference. I also say, I criticize some of the GAN outputs for its frequently banal visuality, about, for it looking like Candy Crush. But I've also relied on GANs to produce this video. So I'm not claiming that GANs, or indeed any other AI-driven art algorithms or techniques, are mindless or evil per se, but I argue that a lot of AI art becomes more interesting when it executes and acknowledges its paragonal function. And the paragon as in, it's not the work of art in itself that is most interesting in this particular case, but rather the framing, literal or metaphorical. So the voiceover, the commentary in the art piece, but also the research, the critical debate, this conference, all of this constitutes the paragon to this phenomenon of AI art. The term comes from art history, but you can also see it in Kant's the Third Critique, and Derrida picks it up in the Truth in Painting. So I'm not really interested in art and creativity as existing in their own disinterested and separate domain, but rather in art remaining in relation with other concepts, issues, and objects, and existing in the cultural and socio-political context. So my lecture today is part of this paragon, this attempt to frame and also reframe the debate on machinic creativity and AI art. So today I want to approach the issue of creativity and artificial intelligence by focusing on the problem of machine vision, but also on the problem with machine vision. In the process, I will embark on an experiment in conceptual engineering. With some help from select computer scientists and neuroscientists, I will explore the possibility of building a perception machine, of a non-trivial variety, no less. The title of my talk draws on two science papers separated by a couple of decades, yet both making a contribution to the debate on the relationship between humans and machines. Heinz von Förster's 1971 article, Perception of the Future and the Future of Perception, in which the concept of a non-trivial machine is introduced, and Gerald M. Edelman and George Enrique Jr.'s 1990 paper, Is it Possible to Construct a Perception Machine? I will engage with those papers in an attempt to build what I call a non-trivial perception machine. My talk will therefore be both conceptual and experimental. Mindful of Andreas Bruckmann's call for paying attention to our language when discussing robots and machines, a call which I see as deeply ethical rather than just pedantic, I want to offer some clarification with regard to the key terms and concepts under discussion. As many of you will be aware, machine vision is a systems engineering discipline that works on the automatic extraction of information from digital images to enable machines to perform tasks requiring human sight and do it faster and more efficiently. Such tasks may include quality control, identification and verification, positioning and measurement, and can be found in applications such as detection systems in self-driving cars, manufacturing, security, or space exploration. Machine vision systems rely on cameras with sensors, processing hardware, and software algorithms. Their software side is underpinned by a cognitive discipline called computer vision, which deals with theorizing how the extraction of information from digital images actually occurs. Although the two terms, machine vision and computer vision, are sometimes used interchangeably. Research in computer vision, whose primary goal is to attempt to teach computers to see and to make this seeing meaningful to them, at least within the parameters of the set tasks, falls under the broad purview of artificial intelligence. In its current iteration, machine vision is aimed to imitate the way humans see the world, and also to learn how to see better, that is, faster and more efficiently than humans. However, in my talk, I'm also interested in what it means for us humans to endow machines with the capacity for seeing. I'm using the term machine vision here more literally, therefore going beyond the industry definition to probe how, or indeed whether, machines can actually see at all. This interrogation will underpin my efforts to explore the possibility of building a perception machine on terms that engage with, but also go beyond, those delineated by biology and computer science. The shift from vision to perception enacted as part of this experiment is not entirely mine. In recent years, many AI researchers have gone beyond the explicit oculocentrism of machine vision to expand its operations to other senses, such as hearing, touch, and olfaction. Expanding their data sources from images to sounds, music, and video, Google is now using the term machine perception in lieu of machine vision. Object recognition still forms the basis of its functioning. However, I'm proposing here that the notion of machine perception needs to shift the focus from the flatness of 2D images to the 3D environment which produces them and which hosts the seeing machine. This more active and dynamic understanding of vision in terms of perception and movement, embracing the term's Latin resonances, which signify catching or taking captive, as we learned from Jonathan Crary, departs from the definition of vision as proposed in the foundational text of computer vision by David Marr, published in 1982, in which vision was understood primarily as a phenomenon of information processing. This framework assumes that the mechanism of primary visual processes, such as edge detection or binocular vision, is computational and works its way from those primary processes upwards in the study of the neural circuitry supposedly enabling vision all the way to the brain. The notion of machine perception I'm using here, adopted in a wider sense than the one offered by Google, aims to address one of the key blind spots of computer vision today: its inability to fully account for how our brains actually work and how the translation process from retinal stimulation through to the neural circuits of the brain occurs, while producing a sensation and an awareness of its sensation, recognized in the form of an image that we see in us. It also aims to raise questions for the postulation of the discrete physiological entity called the brain as the core organ of perception. Notwithstanding the unidirectional and linear shift from the eye to the brain in many dominant studies of human vision, the exact location of perceptive processes and their operative mechanisms remain unclear, not just in humans, but also, for example, in frogs. Machines, in turn, interpret images very simply, as a series of pixels, each with their own set of color values. The notion of machine perception thus aims to complicate the simplicity of this model and to explore a different way of what it might mean for machines to see. So let us now move on to conceptual engineering, which is my take on the practice of speculative design, whereby a prototype is made not just from things, but also from ideas. As mentioned earlier, the concept of a perception machine has been inspired by these two science papers. And there are good reasons for turning to them, as their authors have played a significant role in redefining physiological phenomena such as perception and vision as programmable. They also took significant steps in trying to redraw traditional disciplinary boundaries in an attempt to find a new way of understanding humans and machines, or even humans as machines. Von Förster was an Austrian physicist and engineer with an active interest in biology, as many of you will no doubt know. He was one of the key participants in the Macy Conferences, a series of meetings that took place between 1940 and 1961, which led to the emergence of cybernetics as a transdisciplinary field studying biological and mechanical systems. Von Förster gained recognition for his work on second-level cybernetics, that is, the proposition that the system's feedback loop needed to incorporate the observer into its operations, with human self-reflexivity becoming part of the cross-systemic operations across different levels. Von Förster was a prolific writer, often veering beyond the confines of his discipline or even science as such, to offer a wider commentary on society and the world. Perception of the Future and the Future of Perception, first presented at the opening of the annual Conference on World Affairs at the University of Colorado Boulder in 1971, is an example of this approach. So the paper opens with a turn to systems theory as a way of thinking about sociocultural change, while also indicating the limitations of the static model of the system. He advises us that change is seen as an aberration to be corrected. And he goes to seek an opening within the system that would allow the execution of human freedom and agency, and its perception that he turns for this purpose. Specifically, he advises us that if we wish to be subjects rather than objects, what we see now, that is our perception, must be foresight rather than hindsight. So in other words, he calls on us not to fall back on the established patterns of seeing things, but rather to follow unexpected routes and pathways, taking a lesson from children. So far, so pastoral. He's of course not the first thinker to evoke the idea of an original untarnished vision as a supposedly better entry point into the truth of the world. Enlightenment philosophers advocating a return to the kind of rationality, or romantic philosophers wanting a return to the state of nature. Poets and avant-garde image makers were there before him. Yet von Förster has some interesting things to say about the current atrophy of perception, for which he blames the commodification of information and an educational system that confuses the process of creating new processes with the dispensing of goods called knowledge. To offer a remedy for the state of events, von Förster introduces the concept of a non-trivial machine, where the machine refers to well-defined functional properties of an abstract entity, rather than to an assembly of cogwheels, buttons, and levers. While a trivial machine is premised on a one-to-one relationship between its input and its output, thus delivering predictable and consistently identical results, in a non-trivial one, its previous steps determine its present reactions. While both systems are deterministic, the second one is unpredictable because its output changes with what it has picked up in the previous cycles of its operation. So von Förster does appreciate the reliable predictability of various trivial systems such as toasters or cars, but raises concerns about the application of trivialization to other systems. And this is where his concept of the machine gets particularly useful for us in the context of this conference on artificial creativity. He takes the example of a student whom he sees as a potentially non-trivial machine, becoming completely trivialized when he enters or she enters a higher level machine, a university, with its predictable teaching and uncreative testing. Tests are devices to establish a measure of trivialization, he writes. A perfect score in a test is indicative of perfect trivialization. The student is completely predictable and thus can be admitted into society. He causes neither any surprises nor any trouble, he writes. While the human, that is the student, is seen here as a machine, still in the process of being constructed in their relatively young age, the higher level operations of the recursive loops enable the possibility of creativity within the system, made up of other machines, educators, forms of knowledge and ways of their transmission, pedagogies and infrastructures, but only if the human agents execute their potential. In other terms, when they acknowledge what Luciana Parisi has identified as the incomputable being part of systemic rationality. Now, it may seem obvious that educators, or indeed most humans, would want to do this. They would want to reach for the systemically determined yet ultimately undefined degree of freedom available to them. Yet such acts of reaching out towards freedom for attempting to change the system's course of action are quite rare. Von Förster's paper ends with a rather humanist call to recognize and cherish the troublemakers, whom he says we will recognize by an act of creation. Let there be vision, he writes, and there was light. Interestingly, though, it is through perception, the way of seeing attentively, that for him, we as educators, evaluators, assessors of students can introduce novelty into the input-output process and thus create a systemic opening. So this could be seen as a first step in attempting to build a non-trivial perception machine. But how do we make students, or indeed anyone, see better without knowing in advance what we want them to see? What kinds of frameworks we are looking through and aiming for? Isn't there a danger that this call on part of von Förster will ultimately sound banal, or indeed trivial, at best vaguely humanist, at worst a recipe for all sorts of educational libertarians to break with the expertise and care developed within the educational system? And we are hearing a lot of these calls these days anyway. So frequently described as a polymath, von Förster is one of a long line of predominantly male scientists who opine on wider societal issues, making quick excursions to scientific models and protocols in order to develop explanations of the world, while demonstrating strange blind spots when it comes to the cultural aspects of systems they write about, including the terminological and ideological determination of their concepts. And of course, all our conceptual frameworks are ideologically determined, but it is the unawareness or obfuscation of this phenomenon, frequently coupled with the ascription of ideology to one's intellectual enemies, that I'm highlighting here as a problem. The model of what we might term truncated rationality is still very much at work in the very hotbed of cybernetic and post-cybernetic thinking, Silicon Valley. A recent book by Adrian Daub, What Tech Calls Thinking, shows what computer science understands as knowledge. But while Silicon Valley is its most visible actualization, this form of truncated rationality exists and thrives in scholarly disciplines such as analytical philosophy, linguistics, biology, cognitive psychology, and neuroscience, a cluster of disciplines that provide intellectual foundations for the field of artificial intelligence. So bearing this criticism in mind, is it possible to construct a perception machine? This question was originally posed by biologist and Nobel laureate Gerald M. Edelman and his collaborator Jordan Reed Jr. in their 1990 paper. Their work was part of their wider project on the neglect of findings from evolutionary biology in AI research. In an article written 2 years prior, they chastised AI researchers for remaining too wedded to, and I quote, epistemological assumptions drawn on the one hand from the arguments of Alan Turing and Alonzo Church about the universal problem-solving capabilities of computers, suggesting that the brain may be understood as a computer, and on the other hand, from the reductionism of molecular biology, suggesting that the brain may be understood as a collection of units that exchange chemical signals, unquote. So Edelman and Reek are also critical of neural network computing as an approach that promises to develop machine vision by modeling it on the operations of the human brain. For this approach is premised on a badly conceived analogy for them between neural networks in the brain and computer networks, and not on the way biology actually understands neural structures. The strictly computational approach, they argue, can't really tell us much about perception because of its foundational error, namely the belief that objects and events, categories and logic are given, and that the nature of the task for the brain is to process information about the world with algorithms to arrive at conclusions leading to behavior. Now, recursive neural networks used in machine or deep learning that consist of layers of nodes can be said to have partly addressed the problem of being unable to deal with the increasing complexity of the problems to be solved. Indeed, they have had significant successes in identifying patterns and trends in imprecise data, as evident in applications such as face recognition, medical data analysis, or natural language translation. Yet neural networks, as currently conceived in AI research, still don't ultimately challenge the assumption that information exists in the world, while the organism is a receiver rather than a creator of criteria leading to information. Now, I'm particularly interested in Edelman and Reek's critique of the idea of objects and events existing in the world out there, to be seen, grasped, and manipulated by us. This critique corresponds to the philosophical theory of conscious realism espoused by Donald D. Hoffman. This theory doesn't claim that there is nothing in the world, only that the preconceived and discretized objects that allegedly present themselves for our vision to capture them are actually outcomes of a creative, dynamic, yet not ultimately determined processes. We see what we need to see, argues Hoffman. The nature of this need is for him biological, or more precisely evolutionary, in the sense that the purpose of what we see is our survival. And this is where his intellectual trajectory coincides with Edelman and Reek's. Indeed, as a riposte to the physicist's computational schematism, they suggest that any viable theory of categorization and intelligence to be used in AI research needs to embrace the Darwinian model of selection, but adjusted for the working of neurons of a single organism operating during its lifetime. This conclusion serves as the grounding for their 1990 paper about the possibility of constructing a perception machine. And indeed, in the paper, they propose such a construct, named without any equivocation or irony, Darwin III. This machine's architecture is premised on their proposition that categorization, rather than more straightforward object recognition as applied in computer vision systems, is a critical component of perceptual systems. Perception does involve the adaptive discrimination of objects or events through one or more sensory modalities, but these objects are not predetermined. For Edelman and Reek, perception is not about grasping representations, as the categories used by the organism or machine don't exist in the world for this organism or machine to then come and recognize them. Rather, those categories are actively constructed, or as the authors put it, they are meaningful to the perceiver in a given situation. Perception thus becomes redefined as an active sensory-motor process, requiring exploration and depending on past experience. In this model, categorization can't be solely expressed in symbolic form. The biological aspect of these organisms implies that movement through the world is needed for recognition, and hence perception and intelligence to be enacted. This model is premised on the interesting idea formulated in the two authors' earlier paper of the brain as a selective system operating in somatic time, one which resonates with the phenomenological approach to AI design, which is increasingly growing in popularity. Yet Edelman and Rick's concept of the perception machine itself remains hamstrung in this acultural model, with machinic operations positioned as primarily driven by natural selection. Cultural transmission of information is dismissed by them as not being relevant to the evolutionary development of working perceptual systems. Even though Darwin III is supposedly more firmly placed in the world, its orientation, vision, and goals are crippled by the temporality of its movement, with somatic time requiring an erasure of the said soma's singularity at the expense of the supposedly timeless operations of natural selection. There is therefore a danger of Edelman and Rick's perception machine ending up being rather trivial, because the information it will pick up on the way to develop its categories, even if collected in a more dynamic and embedded way, will by design have been stripped of any cultural specificities, which here only amount to noise. However, designating which aspects of the surrounding can be classified as nature and which belong to the realm of culture is not so straightforward. In his poignantly titled article, Beyond Biology and Culture, The Meaning of Evolution in a Relational World, anthropologist Tim Ingold argues that the difference between nature and culture is just a matter of temporality. History, which manifests as culture in different epochs, simply operates on shorter timescales than evolution, which supposedly proceeds according to laws of nature. Ingold goes on to show how Darwin's The Origin of Species challenged the 18th century view of man as being equipped with special characteristics such as reason and morality, characteristics which were meant to separate him from the other species. Darwin postulated that the difference between the human and other animals was in fact one of degree, not of kind, and that evolution, which he had originally termed descent with modification, was the manner through which the change towards a rational man with his intellectual and moral faculties happened. Yet the problem with that view was that it inaugurated another differentiation, which today we would rightly describe as racist, one between the savage and the civilized man. The only way out of this dilemma was to attribute the movement of history to a process of culture that differs in kind, not degree, from the process of biological evolution, writes Ingold. It was also to put forward the idea of two parallel kinds of inheritance in human populations, one biological, involving the transmission of genetic information encoded in the DNA and referring to the core identity of the human, the other cultural, taking place through social learning. Now, Ingold's argument, which builds on the work of psychologist Daniel Lehrman, poses a challenge to any attempt to construct perceptual systems which will be capable of passing on their evolutionary traits to their offspring, but which will not pass on any cultural influences. Any traits that will get passed on will always carry both natural and cultural inscriptions in a manner that will not allow for their easy decoupling. But the construction of culture as a separate domain of uninheritable features will perpetuate this distinction while allowing computer scientists to forego embodied and embedded models of perception and cognition. This disembodied model of computer vision results in the preservation of one of the biggest science and computer science myths, the belief that data bias, understood as cultural bias, once eliminated, will result in the data that is both pure and fair. We are regularly presented with consequences of such essentialization of biology and the brain at the expense of cultural traits in cognitive and computer science. And two recent examples include the video conferencing platform Zoom's background algorithm, which removed the head of a Black academic anytime he tried to use a virtual background, and the Twitter cropping algorithm, which always privileged the showing of white faces in cropped images in the timeline. So while the computer vision machine reveals itself not to be particularly perceptive, the consequences of its racialized blind spots are anything but trivial. Indeed, the algorithms that run within it are the same ones that make decisions about people's social, financial, or legal status, including punitive action and border control, denial of credit, prediction of educational failure, or assignation of criminality. While early Google image recognition algorithm was highlighted in 2015 to auto-tag pictures of Black people as gorillas, there is an ongoing problem with face recognition of Black females, with a high false match rate explained by industry experts as a combination of the difficulty of lighting a Black face and the makeup worn. Denying explicit bias, Thorsten Thies, director of algorithm development of German company Cognitech, which supplies facial recognition systems to governments, explained in a troublingly disarming manner that it is harder to take a good picture of a person with dark skin than it is for a white person. One factor is that the image databases that serve as training sets for the algorithms are not properly representative, being skewed in terms of volume and quality towards photographs of white males. But there is a deeper logic at work here, with a whole systemic infrastructure involved in the production of cameras, lighting systems, image processing software, and the visual and cultural training of photographers and image technicians that produces a particular set of internalized norms that can be presented as posing an objective difficulty in taking a photo of a person with a dark skin. This mode of thinking, embedded in all sorts of technologies that precede the digital, is what Sophia Noble has described in her book Algorithms of Oppression, which analyzes the hidden operations of race, capital, and gender in algorithmic infrastructures as technological redlining. Suggesting that artificial intelligence will become a major human rights issue in the 21st century, Noble issues a clarion call for us all to understand the architecture and logic of algorithmic decision-making tools in masking and deepening social inequality. Noble then puts to rest the belief in glitches as occasional aberrations, which can be easily eliminated for the functionality and efficiency of the supposedly neutral system to be restored. CDO at Twitter, Dantley, responded to the cropping algorithms debacle with a chest-thumping yet predictable, "It's 100% our fault. Now the next step is fixing it." Yet Noble leaves us no illusion that algorithmic oppression is fundamental to the operating systems of the web. It's therefore not enough to just debias the data. Rather, we need to ask bigger questions about the forms of injustice embedded in the systems that host it. We also have to ask what it means when the elimination of the glitch, while desirable from a technical point of view, ends up making the punitive surveillance running on this data even more efficient. The correction of the data bias doesn't correct the violently penetrative and extractivist logic of the computer vision system. It actually strengthens it. We could thus say that we need to identify the unjust operations of the non-trivial vision machine before we start thinking of building a non-trivial perception machine. As you can hopefully see by now, I'm proposing here a conceptual expansion of the notion of the machine. In line with its cybernetic legacy from von Förster and colleagues, the term machine departs from its strict engineering connotations to embrace any kind of system, be it mechanical or biological, of a varying degree of complexity. In this framework, systems are arranged in a nested manner, from the microscopic to the cosmic, while undergoing internal transformations or even cross-systemic mutations. In the 1960s and 70s, the cybernetically inflected notion of the machine became a potent concept for philosophers and cultural theorists attempting to articulate different levels of socio-political complexity while taking into account societies and individuals' biological and technical constitution. We can think here of Gilles Deleuze and Félix Guattari's war machines or desiring machines, through to Michel Foucault's dispositif or Willem Flusser's apparatus. So building on this legacy, we should recognize that the perception machine we are attempting to build will espouse multiple, albeit interwoven levels of meaning. To begin with, the term has biological connotations, signifying the system of perception in human and non-human animals. The perception machine is also a technical machine understood as an apparatus, perhaps a camera. Perception here is read as a form of image making, involving apparatuses such as cameras, telescopes, and scanners, but also the wider technical infrastructure supporting those devices. Thirdly, the term has connotations of the Foucauldian dispositif and the Flusserian apparatus, referring as it does to a wider socio-political setup, while also conveying the possibility of adjusting the machine's program to enable different behaviors and different modes of acting. The concept of the perception machine thus highlights the interlocking of scientific and cultural discourses in the production of images, and the production of subjectivity and objectivity as functions of all kinds of images. The perception machine can therefore also be said to stand for nothing less than what we humans call the world, and for the mode of its production for us humans. And I'm aware that what I'm doing here goes directly against Andreas Brockman's call from yesterday's keynote not to extend the notion of the machine beyond some specific apparatuses to larger symbolic and social systems. So you can see I come at it from cybernetics and take the opposite view. But I believe I'm also in agreement with Andreas when it comes to the rationale for what we do. I think both projects are driven by an ethical injunction to make knowledge that matters and that counts, that is anchored in specific affordances, and that can tell us something meaningful about us and the world. We just get there differently with different concepts. So for me, it's only through a radical conceptual expansion of the concept of the machine with its nested layers of meaning that we may approach this goal. Such operations are not just metaphorical. There is a materiality to these different layers and their operations, and there is an intellectual trajectory and tradition to them too. So in my attempt to build a non-trivial perception machine, I'm not really constructing a device, but rather building a conceptual framework, a scaffolding for both framing what we term the world and seeing this world better. Such a perception machine will have to do more than just identify symbols, avoid bias, or even counter with the environment. In its architecture, the idea of the brain as a discrete perceptive organ will need to give way to a dynamic interaction between the organism with its constantly changing embodiment and the environment, which is not a constant for it, but which exists only in relation to the organisms that inhabit it and embodies a history of interactions with them, as Ingold puts it. Indeed, there is no perception machine outside of its cultural and historical embeddedness. The very gesture of embarking on the task of trying to build a non-trivial perception machine is also meant to serve as a multi-scalar attempt to rethink our human perception and vision, and to challenge the parameters of the vision machine that has been an emergence in our globally networked world. In his 1994 book, The Vision Machine, Paul Virilio traced the transformation of vision in the 20th century from the technology of warfare in the Great War, which turned vision into visualization, through to the industrialization of vision, which shifted the majority of activities unfolding within the field of visibility from humans to machines. The current vision machine we are living in is both a surveillance machine and a data capture device. It's also, as pointed out by Virilio, a war machine, serving as it does as a digitized battleground featuring multiple operations of capture and carnage, with real-life consequences for human and non-human lives. A non-trivial perception machine we are building here will need to be able to scan through its obscure logic, To do this, such a machine would need to be more than just neutral or unbiased, although it should be that too, but also must be decisively anti-racist. We could go even further and suggest that to counter both the racist legacy of the war machine and the capitalist extractivism which fuels it, it must also, following Ariella Azoulay, be counter-imperialist. And now I'm just doing a little postscript to my talk. And as part of this, I wanted to show you this project called The Recognition Machine by Dutch artist Antje van Wiegelen, who also worked with other artists in the project's different installations. I first saw it at the Fotoscene in Cologne last year, but the project also has an online counterpart. Looking like a photo booth, the Recognition Machine invites gallery visitors to enter and take a photo of themselves. The act of taking a photo activates an algorithm that attempts to establish links between the pixels just recorded and those of images from a database of 19th century anthropometric photographs, which have been transformed by analog techniques. The resulting print output links contemporary regimes of surveillance to those of a colonial past. The link between the images pivots around the emotions identified by the algorithm in the viewer's face and linked with the emotions read in the archival photos. The reading was obtained by training the algorithm on the FIR 2013 dataset, in which each image had been assigned one of the emotions, anger, sadness. She's doing it kind of critically, ironically. The visitor may keep the print, but they are also asked to explore further the posited analogy and thus go deeper both into the archive and the colonial history of portraiture. The recognition machine shows us that all images exist as part of the imperial colonial network of visuality, a network that renders some bodies as visible and proper while deeming others as illegible and or illegal. So this is a model of the perception machine as an invitation to study the production of visuality, the image networks and their infrastructures, their underlying data and databases, the algorithms that shape both their production and their networking. A non-trivial perception machine encourages an ethical political engagement with images, their histories, databases and infrastructures. Thank you.
Thank you very much, Joanna, for this rich lecture and a very thought-provoking talk. Now is the time for our attendees and panelists to enjoy. And I can see that the first question is already here from Brad Gallagher. Have you given any thought to the inherent pleasure or joy of perception in your research? I'm thinking about YouTube videos that show deaf people hearing for the first time or colorblind people seeing color for the first time, and the overwhelming joy this apparently produces as powerful examples. To create a perception machine, will it need to experience some analog to this pleasure or joy?
Thanks, Brad. That's a great question, and the answer is no, I haven't. But it's something that I would like to explore as part of a wider project, which concerns the kind of industrialization of vision, but also looking for some kind of biological counterparts of phenomena and kind of ways of experiencing the world and describing it in some way. So I think part of me is also slightly suspicious of joy as this kind of unadulterated, pure term that can be stripped off our ways of kind of understanding, connoting it. At the same time, I think, there is something kind of really interesting there that is definitely worth probing. And I think what your question points to very interestingly as well is this model of distributed perception, how perception, it's not just about the eyes, but it's also about different ways of kind of picking up senses. And even the visual perception, which, in everyday parlance, we very often, the terms are used interchangeably, partly because for us humans, the visual is such a strong framing apparatus. So I think it's something to think about more thoroughly. Anyway, thank you.
Thank you very much. While we're waiting for the next question, this is more like a comment rather than a question. When you spoke about bias, and especially this kind of inherently kind of a racist framing in some cases, I'm wondering to which extent the reason for it lies in the fact that the origins of the what we refer to as AI, in the lack of a better term, lies in this post-war military technology, and so many scientists that actually employed literally these military instruments and knowledge to this kind of emerging field at the time. Majority of scientists who worked back then were male and white and middle class. And then more importantly, they also framed the terminology around this emerging field. Mm-hmm. I'm hoping that my question is kind of not too intentionalist, but I'm just curious to hear your opinion about it.
Yeah, I mean, I think you're absolutely right that we need to look at the kind of histories of the construction of the kind of databases and technologies. And there are a lot of people doing research around this. And many panelists throughout this conference have already referred to the work that identifies this. So I think, the particular histories of particular technologies and ways of seeing, ways of devising knowledge are tied in to particular both apparatuses and epistemological frameworks. So there is that. I think there is also something else. There is a deeper belief, which is much more maybe in line with the kind of scientific paradigm, in the possibility of having a pure data set. So in the sense that you can debias it. What I'm trying to show this, I think it would be very difficult to just perform the operation of debiasing. I mean, there could be obviously a data set which is less racist than, more racist, but there is, I think, a broader political issue for which the kind of debiasing won't fix it. So on the one hand, I think there's historical antecedents as well that have shaped it a particular way, but also I think there is more seemingly innocuous idea, the belief in the objectivity of knowledge that is underpinning all of this. And I think coming from the humanities, come already with a suspicion of this, of this belief.
Thank you very much. We have a question. Is there any particular reason to think about a machine, singular, or could one consider a plurality of vision perception machines?
No, absolutely. I mean, it is necessarily a plurality, both in this conceptual engineering experiment I've proposed, but also in the theorists from whom I've borrowed, and both in the cybernetic trajectory, which I try to use both faithfully and playfully, but also in the kind of philosophers such as Deleuze and Guattari and Flusser or Foucault, who are taking this machine and this notion of the machine, and then it's got a number of different iterations. So in cybernetics, the machine is always already embedded in other machines, a nested system of machines. So the machine I refer to as a concept, but it's got lots of different iterations and also lots of different scales. And again, for this project, not to be just an intellectual conceptual exercise, but to execute its ethical ambition that I have for it as part of the intellectual inquiry, it has then to look at these singularities of enactment. And this was my attempt to read and to be disappointed with that kind of biology paper by Edelman and Rieck, where they talk about kind of the body, the brain and the somatic time, and that somatic time, which always requires a notion of singularity, is kind of overlooked, if you like.
Neil Leach has a question. He says that Anil Seth and Andy Clark from University of Sussex are the two key figures here in computational neuroscience. Perception here is seen as predictive and understood as a form of controlled hallucination. Mema Acton has linked neural networks to this approach, illustrating how human vision is not so different to the way that a neural network is trained. In other words, the machine hallucinations of AI are not dissimilar to the controlled hallucinations of humans.
Yes, thank you for this question. And I think I would probably want to decouple it because it talks, for me at least, about two different things. And I found Anil Seth's in particular work very interesting with regard to opening up the notion of perception and trying to see it in a kind of more embodied and more kind of phenomenological, more in the world way. And it's almost, for me, as coming from a kind of philosophy background, this is also a kind of science as philosophy. And I'm aware that not all neuroscientists are necessarily in agreement with Anil Seth or Andy Clark, truth be told. But the question about kind of Memo Acton's project, I suppose, and some other projects that, Memo Acton's Hello World, and the project I find visually very seductive, very interesting in the way it poses certain questions, but I'm also wondering to what extent there is a certain posited similarity between different kind of forms of systemic vision that tries to strip off certain, if you like, acculturations of what we understand as perception and return to this idea of core vision that can be found in the way kind of computer vision systems design vision. And for me, there is a problem with that. I think about the foundational assumptions about the understanding of vision and whether, that understanding be functionalist or whether that be, focused more on results. I'm kind of not really sure. So I've kind of done some probing of the way works, artists and, Acton is also a computer scientist, how they kind of define computer vision in their work. And I'm kind of not really sure.
Thank you very much. Andreas Brockman asks, how does human visual perception relate to the perceptual operations of the perception machine? Where would you position the human in relation to the perception machine?
Well, if we're using the term, if I'm using the term, the perception machine here as this kind of quite large concept, and it's a concept, I said, it's more than a metaphor, but it's something that is meant to allow me to kind of think about all these different interlinked layers of what we could call, for the lack of a better word, reality. So the human would be one of those layers in the system, while also you could apply that notion of the perception machine, and that goes to back to the previous question about the plurality of machines. So the human would be one of perception machines, while also both relying on lower level perception apparatuses, perception machines, and constituting part of the kind of larger machine. And non-human photography, I kind of tried to play with this idea of the universe being a kind of giant camera, and this idea of the universe being photographic. And that was already my first steps towards thinking about this idea of perception happening at cosmic level. And but then again, going back from that and looking at the affordances and specific executions of particular functions, particular ways of enacting something. So I realized there might be a danger, and Andreas and I, we had conversations about this over email places about collapsing all these different levels. And then if everything is the perception machine, what isn't, and how is this concept useful? For me, it's a kind of way to propose a certain alternative framework that acknowledges complexity, but also serves as a kind of critical tool. And another concept that's been important to me in my kind of philosophy work over the years is the notion of the cut. The notion of the cut, and that you find it in Bergson, you find it in Deleuze, but also Karen Barrett has got the notion of the agential cut. But the cut is this kind of temporary resolution of this layering, if you like, or of these systems. So there isn't just a flow of all the different bits of data. There isn't just a kind of nested tree or nested structure of all these perceptive machines. There are also moments of the cut that the human who is doing the analysis, and in this moment myself here, has to make that cut. The position of anchoring needs to give an account for and make cuts which are both perceptive and are cognitive. And that cut becomes a moment of presenting some sorry, I've run out of words now, but I can see some
Yeah, Andreas actually has a follow-up question. Does that make perception a form of interaction?
I suppose so. I mean, I think interaction is probably not so much part of my vocabulary, but it's not to say that it's wrong. But I suppose if that relationship, of perception is positioned as dynamic, and again, it's not just my idea, it's taken from, for example, say the second level cyberneticists, such as von Förster or Stafford Beer and others, then I suppose so, yeah.
Thank you. And now I have the last question by Kelly Wagman. Could you say more about the interplay between perception and objectivity? Is it possible for perception machines help humans be more objective?
I suppose the concept of objectivity is not something I am comfortable kind of working with. And again, to say that I'm not comfortable working with objectivity, it's not to say that, I think everything is relativist. So for me, objectivism and relativism are not in opposition here. But I think objectivity, you would need to account for the position of the observer who is offering a certain viewpoint and standpoint. And again, I'm borrowing both from cybernetics here and from Donna Haraway's essay on situated knowledges, in which an account of a position from which one speaks would need to be given, and a realization that a different observer, as both an embodied and a cultural historical subject, will have that different viewpoint. So I'm not sure whether objectivity is necessarily the word that I would work with here. And yeah.
Thank you very much. Once again, we are very pleased that you took part in our conference and for your wonderful keynote lecture.